This video will continue our ball game, adding more details into the program. The code we are working with is ball1a.rs. Let's run the code first to see how the program runs. This time, the player is made up of two balls, one is called the head, and the other is called the body. We use the same code to drive the head as we have seen in our previous video. Now we will see how we move the body. The connection between the head and the body defines the direction of the force applied to the body. Newton's second law is used for the calculation of the movement of the body. The force has two components, one from the head, and the other is the friction. Imagine there is a spring between the head and the body. We reshape the equation, so we have the Rocking equation like this. Alternatively, we can use this form. Let's examine the code. This is the pi value. This is the use definition, nothing special here. These are some constants we will use soon. This one is important, representing the equilibrium or rest length at which the force generated by the spring is 0. Let's first look at the struct head. The head has three fields. Essentially, it is the player in our previous code, with the radius and color removed. We change the type of position from POS2 to VEC2. The body has two fields, but the velocity is a two-dimensional vector. As before, we bind a few functions to the head. The initial speed of the head is not 0. These two functions are the same as before. We separate the tick function into two. Basically, the paint function is the same as before. Here you can see the reason why I removed the field's radius and color. Let's implement some functions for the body. The default values for the position and velocity are related to those for the head. The function tick for the body is not as difficult as it looks. Delta is a 2D vector. It has an orientation. This is Hooke's law. This is the formula we just derived. Now it's ready to update the position. This is the paint method, painting a circle. The struct myGame has three fields, paused, head and body. The previous code had two fields. The new and reset methods are the same as before. The keyword pub is not necessary, so I removed it. The trait default is implemented for myGame. If we look at the default position values of the head and body, we will notice that the head and body are separated by the distance of the rest length of the spring. Note the way we implemented the default trait in our previous code. Let's examine the update method. Here the positions of the head and body are updated. To calculate the force applied to the body, we need the position of the head. The code handling the keyboard events is the same as in our previous program, except that we use arrow keys instead of the W, A, S, and D keys. Correspondingly, we modified the function showInst. Let's compile and run the application. Let's move on to our next script, ball1b.rs, which makes the player growable. First, we borrow the code from the ball1a.rs, including the use declarations, definitions of the constants, and anything related to the struct head and body. We then define a new struct called worm, which has two fields, head and units. The head is the same as in our previous code. The units field is a vector containing bodies. As we already know from in our previous videos, a Rust vector is a continuously growable array. Currently, t equals body. We are going to implement 4 functions for worm, moveMe, bounce, grow, and shrink. Let's start with the first one, moveMe. For any body, we need to know the leading body for the calculation of the pulling force. Please pause to understand the code. Since we already implemented the bounce method for the head, here we just call the method. Here, growing the worm means growing the vector. Therefore, we need to define the body. The problem is with the default position value. We need to modify it. That's why we use the keyword mutable. The if-let-else structure is very important. If you don't know what it is, check this link. Simply put, the code says, if the vector is empty, we reach the else block. Otherwise, the last function returns some body called b. Then we take b's position. The shrink method removes the last element from the vector. Finally, we have the struct myGame with 2 fields. We have seen this multiple times. This is the implementation of the default trait for myGame. The general organization of the update method is the same as in our previous programs. The key part of the code involves the update of the worm's position, as well as the growth and shrink of the worm. This line moves the worm. This line checks for boundary collision. If the G key is pressed, the worm grows. If the S key is pressed, the worm loses a body segment. For every frame, the worm is drawn on the screen. Finally, this is the code for keyboard events controlling the motion of the worm. Let's have a look at the full code. And run our application. Thanks for watching.